Deploying large language models efficiently requires a scalable, reliable, and cost effective solution. That's where dstack and Vultr come together to simplify AI infrastructure management. My name is Mridul Swaroop and I am a developer advocate here at Vultr. And today I am excited to guide you through how dstack makes LLM deployments effortless while leveraging Vultr's high performance cloud infrastructure. In today's Tech Talk, we'll understand how dstack simplifies AI workflows, focusing on its core components, services, and tasks. Then, we'll explore how Vultr's global cloud platform enhances dstack's capabilities with reliable, high performance computing. Finally, we'll dive into how these technologies work together to create a seamless and scalable ecosystem for deploying LLMs with minimal complexity. Let's begin by understanding what dstack is and how it stands out. Dstack is an open source orchestration tool purpose built for AI workloads. Unlike general purpose orchestrators like Kubernetes, dstack is specifically tailored for challenges with AI deployment and development. Its primary goal is to streamline workflows for tasks like model training, fine tuning, and deployment. What makes it versatile is its compatibility with various environments, whether you are working in the cloud or on premises. It also supports a wide range of hardware, including NVIDIA GPUs, AMD GPUs, and TPUs, giving AI teams the flexibility to use the best tools for their projects. With dstack, you can orchestrate your AI workloads efficiently while cutting down on operational complexity. Now let's understand what are dstack services. Dstack services simplify the deployment of long-running applications such as APIs, ML models, or web apps. Instead of managing infrastructure manually, developers can define services using simple YAML configurations. Dstack takes care of provisioning, scaling, and maintaining reliability on both on-cloud and on-prem environments. This ensures that applications scale seamlessly while optimizing resource utilization. Whether you are running an AI model in production or hosting a web service, dstack services provide a hassle-free way to manage and deploy your workloads. When it comes to running AI and machine learning workloads, dstack streamline the process with each task representing a specific job, whether it's training a model, processing data, or running an inference pipeline. Users can define tasks in a lightweight configuration file, specifying resources like GPUs, dependencies, and scripts. Dstack then takes care of scheduling, execution, and resource allocation, ensuring efficient workload management without the complexity of manual orchestration. This makes it easy to scale AI operations while maintaining performance. Finally, let's discuss how dstack works with Vultr to supercharge your AI workloads. With dstack, you can easily deploy and orchestrate your workloads across Vultr's infrastructure. Vultr offers high performance compute and flexibility in scaling, making it an excellent match of dstack's capabilities. Additionally, Vultr provides a cost effective solution as compared to other cloud providers, helping you optimize your infrastructure while maintaining high performance. dstack's ability to manage resources efficiently combined with Vultr's scalability means that you can run AI workloads of any size, whether it's training a massive model or deploying it as an endpoint. Lastly, Vultr's reliability ensures your AI models and services are always accessible, further enhancing the end-to-end capabilities of dstack. Next up, we have a demonstration in which we are going to deploy an LLM using dstack services and fine-tune a LLM using dstack tasks. The first step of our demonstration is to create a dstack virtual environment. So let's go ahead and create a virtual environment. Now the second step is to activate the virtual environment. Once the environment is created, it's time to provide the first configuration, where we will provide Vultr as the provider. Now we'll create a YAML file where we will declare Vultr and our Vultr API key. As you can see, I already have my YAML file. This is the similar YAML file if you want to declare Vultr as the provider. So let's go ahead and save this file. Now let's install dstack in our virtual environment. Now it's time to start the dstack server, which will provide us with the unique URL where the server is running and the token to access the server. As you can see, our server is up and running and we have been provided with the server to URL and token to access. We'll open another terminal window. Once you have created another terminal window and activated your virtual environment, now it's time to connect with our dstack server. Here, please ensure you replace the token with the token provided with your server activation and the URL on which your server is activated. So let's go ahead and connect with the server. Now we'll create a quick start directory. In this directory, we'll initialize dstack. Now it's finally the time in which we are going to create a service file in which we'll tell dstack which LLM model to deploy. Here we'll paste our YAML configuration file. As you can see, I am deploying DeepSeek R1 model on Vultr L40S Cloud GPU. So let's go ahead and save this configuration file. Now it's time to apply this file and tell dstack to deploy the DeepSeek R1 model. As you can see, once we apply the configuration file, our plan is getting applied. dstack will try to provision instances on our Vultr customer portal. We have specified that we want L40S GPU card to be provisioned. So let's go ahead and submit the run. Right now, the dstack services are trying to deploy an instance. As you can see, the server status is now changed to provisioned. You can also verify the status of your Vultr instance provisioning by going into the Vultr customer portal. So let's go ahead and visit the Vultr customer portal. Here, as you can see, I have an instance automatically provisioned which is named main DeepSeek R1 NVIDIA. That means dstack is in the process of deploying the DeepSeek model on our L40S GPU. The model deployment can take anywhere to 15 to 20 minutes. You will be notified via terminal where the model is deployed. After you have deployed your first LLM with dstack using Vultr GPUs, now it's time to fine-tune an LLM using dstack tasks. So one of our first steps would be to create a configuration file in the same environment in which we created the service. So let's go ahead and create the configuration file. Here I will paste the configuration. As you can see, here we will be fine-tuning DeepSeek R1 distill model and we will be again using the L40S GPUs. So let's go ahead and apply this configuration. As you can see, the plan is getting applied. dstack will find the relevant services to provision and this is how the fine-tuning will be done. The fine-tuning procedure will take around 2 to 3 hours to fine-tune the model. The fine-tuned model will be saved to your system. You can use it later to again deploy a service. As you can see, our server is getting provisioned. This server is different from the one we provisioned before. This server will be used to fine-tune the model. Here in our YAML file, we are using wantDB. So you will need to provide the API key. The documentation for this demonstration is provided in the description. You will need to have a 1DB account to track the metrics of fine-tuning process. This is it for this demonstration. This brings us to the end of today's Tech Talk. We have explored how dstack simplifies AI workflow orchestration and how Vultr's cloud infrastructure enhances scalability and performance for deploying LLMs. By combining dstack's powerful automation with Vultr's high-performance compute, developers can seamlessly deploy, scale, and manage AI workloads without the complexity of traditional infrastructure. Thank you again, and I hope to see you in the next one.